National Electrical Code Section 700.15, titled Loads on Emergency Branch Circuits, does not mandate separate automatic transfer switches, also known as ATS, for emergency lighting and security equipment. The definition of a branch circuit, as found in National Electrical Code Article 100, pertains to the circuit conductors located between the final or recurrent protective device and the outlet, or outlets. This definition technically permits multiple branch circuits to be supplied from a single panel board fed by one ATS. National Electrical Code Section 700.12b specifies that emergency circuits must have an independent overcurrent protective device on the supply side of the automatic transfer switch. This ensures that faults occurring on the normal power source do not compromise the emergency circuits. In practical application, the utilization of separate automatic transfer switches for emergency lighting and security equipment is frequently recommended. This approach offers enhanced redundancy and isolation, thereby bolstering overall system reliability. However, this is generally considered a best practice, rather than a strict code mandate unless specified otherwise by local authorities. Several factors can influence the need for dedicated automatic transfer switches. Firstly, local amendments to the National Electrical Code adopted by specific jurisdictions may contain provisions mandating separate automatic transfer switches. Secondly, building codes may stipulate additional requirements for emergency systems, including the configuration of automatic transfer switches. Thirdly, the authority having jurisdiction, abbreviated as AHA, holds the responsibility for plan reviews and inspections. This authority may interpret the code in specific ways that necessitate the use of separate automatic transfer switches. To ensure compliance and preempt potential issues, it is highly advisable to consult with the authority having jurisdiction prior to commencing the installation of an emergency system. The authority having jurisdiction can furnish precise guidance concerning the specific requirements and interpretations pertinent to a given project. When designing emergency systems, you should consider a few things. Firstly, verify local amendments to the National Electrical Code to see if they have more strict rules about automatic transfer switches. Secondly, review the current building codes in place to make sure that these codes do not have any other requirements for emergency systems or automatic transfer switches. Thirdly, discuss the project with the authority having jurisdiction to understand how they apply the code and what they expect for emergency systems. The use of separate automatic transfer switches for emergency lighting and security equipment is a design choice that improves the reliability and redundancy of the emergency system. Although the National Electrical Code does not require that separate automatic transfer switches be used, you should refer to local amendments, building codes, and the authority having jurisdiction. A single automatic transfer switch feeding a panel board that supplies emergency lighting and security circuits may be permitted under the National Electrical Code, but you need to ensure that the requirements of Section 700.12b are followed. You should consult with the authority having jurisdiction to ensure compliance with their expectations and interpretations. The best approach is to reach out to your local authority having jurisdiction and discuss the specifics of the project so that any concerns are addressed and the design ensures that all requirements are met. It is important to remember that these requirements are put in place to protect the building occupants during an emergency. Emergency systems are designed to provide power to critical systems such as lighting, fire alarms, and communications equipment. It is very important that the emergency systems function when normal power is lost. When designing the emergency system, the design should have redundancy and reliability. This redundancy and reliability can be accomplished by utilizing separate automatic transfer switches. You should review the project requirements and design the system accordingly, and consult with the authority having jurisdiction to ensure that the project meets all requirements. When using a single automatic transfer switch to supply multiple emergency circuits, it is very important to use properly sized overcurrent protection devices to protect the emergency circuits. The overcurrent protection device should be sized according to the ampacity of the conductors and the load that it supplies. You also need to ensure that the overcurrent protection device can interrupt the available fault current at its terminals. A short circuit study may need to be performed to determine the available fault current. When performing maintenance on the emergency system, you should make sure that you follow the manufacturer's instructions and all applicable codes. The emergency system should be inspected and tested on a regular basis to ensure that it is functioning properly. If any problems are found, they should be corrected immediately. Emergency systems play a critical role in protecting people and property during an emergency. By following the code requirements and best practices, you can ensure that your emergency system is reliable and will function as intended when needed. Some common issues with emergency lighting include the failure of the battery backup system, bulb failure, and wiring issues. It is important to check the emergency lights regularly and replace any bulbs or batteries as needed. Wiring issues can be more difficult to diagnose, but it is important to check the wiring for any signs of damage or corrosion. The automatic transfer switch is a critical component of the emergency power system. The automatic transfer switch is responsible for automatically transferring the load from the normal power source to the emergency power source when a power outage occurs. It is important to inspect the automatic transfer switch regularly and make sure that it is functioning properly. Some common issues with automatic transfer switches include contact wear, coil failure, and control circuit problems. It is important to have a qualified electrician inspect and repair any problems with the automatic transfer switch. Emergency generators provide a reliable source of backup power during a power outage. It is important to maintain the emergency generator properly and test it regularly to ensure that it is functioning properly. Some common issues with emergency generators include fuel problems, cooling system problems, and lubrication problems. It is important to follow the manufacturer's instructions for maintaining the emergency generator. The fire alarm system is a critical component of the building's safety system. The fire alarm system is responsible for detecting fires and alerting occupants to evacuate the building. It is important to test the fire alarm system regularly and make sure that it is functioning properly. Some common issues with fire alarm systems include detector failures, wiring problems, and control panel problems. It is important to have a qualified technician inspect and repair any problems with the fire alarm system. Emergency communication systems are essential for coordinating emergency response efforts. Emergency communication systems can include two-way radios, public address systems, and telephone systems. It is important to test the emergency communication systems regularly and make sure that they are functioning properly. Some common issues with emergency communication systems include battery failures, antenna problems, and wiring problems. It is important to have a qualified technician inspect and repair any problems with the emergency communication systems. The National Electrical Code provides requirements for the installation and maintenance of emergency systems. It is important to follow the National Electrical Code requirements to ensure that the emergency system is installed and maintained properly. Some of the key National Electrical Code requirements for emergency systems include requirements for wiring methods, overcurrent protection, and grounding. It is important to consult with a qualified electrician to ensure that the emergency system meets all of the applicable National Electrical Code requirements. Building codes provide requirements for the design and construction of buildings. The building codes include requirements for emergency systems. It is important to follow the building code requirements to ensure that the emergency system is designed and constructed properly. Some of the key building code requirements for emergency systems include requirements for emergency lighting, emergency power, and fire alarm systems. It is important to consult with a qualified engineer to ensure that the emergency system meets all of the applicable building code requirements. The authority having jurisdiction is responsible for enforcing the National Electrical Code and the building codes. The authority having jurisdiction has the authority to approve or disapprove emergency system installations. It is important to consult with the authority having jurisdiction before installing an emergency system to ensure that the installation will be approved. The authority having jurisdiction may have specific requirements for emergency systems that are not included in the National Electrical Code or the building codes. It is important to be aware of these requirements before installing an emergency system. Emergency lighting is required in many buildings to provide illumination during a power outage. Emergency lighting is typically powered by a battery backup system. The battery backup system should be tested regularly to ensure that it is functioning properly. Emergency lighting should be located in areas where it is needed to provide safe egress from the building. Emergency power is required in many buildings to provide power to critical systems during a power outage. Emergency power can be provided by an emergency generator or by a battery backup system. The emergency power system should be tested regularly to ensure that it is functioning properly. Emergency power should be provided to systems such as fire alarm systems, emergency lighting systems, and communication systems. Fire alarm systems are required in many buildings to detect fires and alert occupants to evacuate the building. Fire alarm systems should be tested regularly to ensure that they are functioning properly. Fire alarm systems should be installed in accordance with the National Fire Protection Association Standard 72. Communication systems are required in many buildings to provide communication during an emergency. Communication systems can include two-way radios, public address systems, and telephone systems. Communication systems should be tested regularly to ensure that they are functioning properly. Communication systems should be designed to be reliable and to provide communication in all areas of the building. The emergency system should be designed to be reliable and to function properly during an emergency. The emergency system should be tested regularly to ensure that it is functioning properly. The emergency system should be maintained in accordance with the manufacturer's instructions. The emergency system should be inspected by a qualified technician on a regular basis. The emergency system should be designed to meet the requirements of the National Electrical Code, the building codes, and the authority having jurisdiction. Consider the following points when evaluating single versus multiple automatic transfer switches. Firstly, redundancy. Multiple automatic transfer switches offer redundancy. If one automatic transfer switch fails, the other automatic transfer switches can still provide power to their respective loads. Secondly, isolation. Multiple automatic transfer switches provide isolation between different emergency loads. This can prevent a fault on one emergency load from affecting other emergency loads. Thirdly, maintenance. Multiple automatic transfer switches can simplify maintenance. One automatic transfer switch can be taken offline for maintenance without affecting the other emergency loads. Fourthly, cost. Multiple automatic transfer switches are more expensive than a single automatic transfer switch. Fifthly, complexity. Multiple automatic transfer switches add complexity to the emergency power system. The engineer designing the system needs to weigh the benefits of multiple automatic transfer switches against the additional cost and complexity. The authority having jurisdiction may have specific requirements for emergency power systems. It is important to consult with the authority having jurisdiction before designing an emergency power system. Local amendments to the National Electrical Code may affect emergency power systems. It is important to be aware of any local amendments to the National Electrical Code. The building codes may have specific requirements for emergency power systems. It is important to be aware of any building code requirements. The design of emergency systems requires careful consideration of the applicable codes and standards. Emergency systems are critical for protecting life and property during an emergency. Emergency systems, especially power, need to meet specific requirements to ensure its reliability and effectiveness. Firstly, the emergency power system must be independent of the normal power system. This means that the emergency power system must be powered by a separate source of power, such as a generator or a battery. Secondly, the emergency power system must be automatically activated when the normal power system fails. This is typically accomplished with an automatic transfer switch. Thirdly, the emergency power system must be capable of providing power to critical loads for a specified period of time. This is typically determined by the building code. Fourthly, the emergency power system must be tested and maintained regularly to ensure that it is functioning properly. This is typically required by the National Electrical Code and the Building Code. Fifthly, the emergency power system must be designed and installed in accordance with the National Electrical Code and the Building Code. This includes requirements for wiring methods, overcurrent protection, and grounding. Emergency power systems are an important part of any building safety system. By following the code requirements and best practices, you can ensure that your emergency power system is reliable and will function as intended when needed. The purpose of emergency lighting is to provide illumination in the event of a power outage, enabling safe egress from a building or facility. Here are some specific requirements that are crucial to consider. Firstly, illumination levels. Emergency lighting systems must provide adequate illumination levels as specified by applicable codes and standards. These levels are typically measured in foot candles or lux and vary depending on the area being illuminated. Secondly, duration. Emergency lighting systems must be capable of providing the required illumination levels for minimum duration, as specified by the applicable codes and standards. This duration is typically 90 minutes, but may be longer in some jurisdictions. Thirdly, transfer time. Emergency lighting systems must be designed to automatically activate within a specified time after a power outage. This transfer time is typically 10 seconds, but may be shorter in some applications. Fourthly, power source. Emergency lighting systems must be powered by a reliable source of power, such as a generator or a battery. The power source must be capable of providing the required power for the minimum duration specified by the applicable codes and standards. Fifthly, testing and maintenance. Emergency lighting systems must be tested and maintained regularly to ensure that they are functioning properly. This includes testing the battery backup system, the lighting fixtures, and the automatic transfer switch. Sixthly, location. Emergency lighting must be located in areas where it is needed to provide safe egress from the building or facility. This includes exit stairs, corridors, and other areas where people may need to evacuate in an emergency. Emergency lighting is a critical component of any building safety system. By following the code requirements and best practices, you can ensure that your emergency lighting system is reliable and will function as intended when needed. The role of security equipment is to protect people and property from harm. To ensure proper operation during power outages and emergencies, it's crucial to understand the specific requirements. Security equipment, like emergency lighting, must have an independent power source to operate properly when normal power is not available. The following equipment is typically required to have emergency power. Firstly, access control systems, allowing authorized personnel to enter restricted areas even during a power failure. Secondly, alarm systems, providing notification of intrusions, fire, or other emergencies, ensuring timely response and evacuation. Thirdly, surveillance systems, recording and monitoring activities to deter crime and aid in investigations, even when the main power is down. Fourthly, communication systems, enabling communication between security personnel and emergency responders, facilitating coordinated responses. These systems demand reliable backup power to function effectively during emergencies, safeguarding the premises and its occupants. It is also very important to consult with the authority having jurisdiction for any additional requirements for the security system.